So now I will show you how to solve our problem using solver in Excel. And you go to data and there is a solver here. If you open your Excel and you didn't see solver here, please go to file, then option, then you choose add-ins. And here you can go. Then here they will show you some tools that you can add in your Excel, and please uh, click in solver add-in, then OK. Then your solver will appear here when you click data. Okay. But before we use solver to solve our problem, you have to uh, input some column and input the formula for those value. So earlier I already introduced you how to what column, what kind of value you have to input here. So let me remind you again. From here, B15 to F19 will be the quantity shift from the supply region to the demand region, from the plant I to market J. And G15 to H19 will equal to either 1 or 0. When it's equal to 1, it means that they will open the plant. And from G15 to G19, that is the plant has the low capacity. And from H15 to H19, if it's equal to 1, it means they will open the high capacity plant. And the next column is the variable cost, because we want to minimize the total cost that is equal to the sum of variable cost and fixed cost. So I create two columns. The first column is for variable cost, and the second column is fixed cost. Then how to calculate the variable cost? Let's see. The variable cost is equal to the total quantity they shift from the plant I to the market J, multiplied by the cost, the production cost and transportation cost from plant I to market J, right? Then we take the sum of those costs. So here I want to calculate the variable cost when I produce and deliver products from the plant I to all the market. So from the North America to North America, from North America to South America, from North America to Europe, so on and so forth. Then you take the sum, you will have the variable cost. If you open the plant in North America to other market, and the same, you just copy from this cell to cell I16 to I19. You will have the variable cost of all the plants. And the second column is fixed cost. Then how we can calculate the fixed cost? We have the fixed cost for the low capacity plant and fixed cost for the high capacity plant. So if we open the low capacity plant, we will have fixed cost is 6,000. And if we open the high capacity plant, we will have the fixed cost is 9,000. So if it's open, it will equal to 1, and if it's not open, it's equal to 0. So that's why I multiply the fixed cost G4 multiplied by the G15 is binary variable, and plus the fixed cost for high capacity multiplied by the binary variable h15. Then you copy the J15 cell to the cell J16 to 19. Okay, and then I will sum the I will calculate the total variable cost by sum of I15 to I19, and the same I will sum the I will calculate the total fixed cost by the sum of J15 to J19. Then I will calculate the total cost is the sum of I20 and J20, the total variable cost plus the total fixed cost. So that is for variable cost, fixed cost, and total cost. And the next column is the total Xij. Xij is the quantity shift from the plan I to the market J. So I will take the sum of B15 to F15. That is the total quantity they ship from the plant in North America to all the market. And the same you copy uh, the formula in M15 and you paste it in M16 to M19. The next column is the capacity of the plant I. So we have two options, low capacity and high capacity. So I use low capacity is 10 H4 multiplied by the binary variable G15 plus the J4 for high capacity multiplied by the binary variable that is H15. And I will copy the formula in N15 and paste to uh, N16 to N19. I will have the formula for other plant. So we finish the column capacity of plant I. And the next one is we have to determine the total quantity shift in to each market. So it will be the sum of uh, the market share in North America, sum from B15 to B19. It means that the total quantity shipped to the market North America from 5 supply region. And copy the formula in B21 and paste to C21 to F21. So you will finish this row. So that's all the formula you have to input in Excel. And from this area to this area, from B15 to H19, you don't need to input any formula. The solver will fill the number here for us. So we have the objective function is minimize the total cost, right? This one is the column for the total cost. Total cost is this one. And the second one, the second constraint is, maybe let me show you so that you can remember. Okay, here. So let's see the first constraint is the total quantity of products shipped from the plant I to J to the market J is equal to the total demand of the market share. It means that this value, the total quantity shift to the market chase has to be equal to the red value here. So I already took the sum of those values. So our constraint is B21 has to be equal to B9 or C21 equal to C9. That is the constraint 1. The constraint 2 is, sorry, this one should be less than or equal. Okay, so the total uh, quantity shipped from plant I to market chase is less than or equal than or less than or equal to mm, the capacity of the plant I. So the total quantity from the plant I, let's say here is North America, shift to all the market has to less than or equal to the capacity of the plant I. So the sum of this one, uh, here I already calculate here, has to be less than or equal to the capacity of plant I. So here M15 has to less than or equal to N15, right? And so on and so forth. The third constraint is y is binary variable is equal to O or 0 or 1. So here we have these two columns for those binary variable, and all the quantity shift from the plan I to plan to the market chase is larger or equal than 0. So all this value has to be uh, larger or equal to 0. So let's solve this problem using solver. So our objective function is minimize. Okay, you have three options, but our objective is minimize. What value we want to minimize? That is the total cost, and here is the K21. So I input K20. So I input K20. By changing the variable cells, it means the decision variable. So I will choose the range of the decision variable is from B15 to H19. Then subject to the constraint, we have three constraints, right? The first constraint is the total demand, total quantity shift, that is B21 to F21 has to be equal to the value of the demand B9 to F9. So okay, at the next constraint is the total quantity shift from the plan I to all the market is M15 to M19 has to be less than or equal to the capacity of plan I. That is from N15 to N19. Okay. At the third constraint is all the quantity shift has to be less than or larger than 0. Maybe I will put it integer. Okay. So okay. The next constraint is yi has to be belong to 0 or 1. It means it's binary variable. So add from G15 to H19 and you choose binary. Okay, then okay, you choose simplex LP, linear programming, then solve. And okay, and they will give you the value for decision variable. So for example, we check here, this column O0, it means that they will not open any low capacity plant. uh, in this column we can see the first one is 0, so it means they will not open any plant in North America. They will open the plant with high capacity in South America, and here they will deliver 12 to North America from South America and deliver to South America 8. And also they will open another plant in Asia with high capacity, and from Asia they will deliver products to Europe that with the quantity is 4, and go to deliver to Asia is 16. Okay, with the total cost is around 23 1,500 $751 dollars. So using solver, you can solve and here they also show us the capacity of plant and the total uh, the quantity shift, and we check here it's the same, so it satisfies the constraint. Okay, that is the first way for you to solve this problem. The second way, you can use software like Cplex or Lingo. So let me open it. You will need to have, I use the Cplex, Lingo. When the problem become more complicated, but for the simple one, you can just use solver in Excel. If your computer don't have Cplex yet or Lingo, you don't have anything, you can go to our school, then ask uh, the people who work in the lab, uh, ask them to install it for you. If I'm not wrong, it's the room 613. So you can go there to install the software in your computer. So okay. So here I already input, but for you, if you just start using Cplex, please file new, then OPL project. Then in OPL project, you put your project name and where you want to locate your file. Then click to add a default run configuration, create model, and create data. Then click finish. So then first you have to input your parameter and your decision variable. So here first n is the number of plant and m is the number of market. So here we have 5 plant and m is equal to 5 market, right? And I input z is the level of the capacity. We have two level, that is low capacity and the level 2 is high capacity. And you input the range for the plant will run from 1 to m. and here in our case is 1 to 5, and the range from market is from 1 to M, and the level is the range from 1 to Z. Z here is 2, and the input for the demand for each market is already known, so I input it integer. And the input for the capacity of each plant of each level is also known parameter, and the fixed cost for each plant we also have, and the cost for production and transportation costs from plant I to the market J already known. And what we want to find is we want to find the quantity uh, shift from the plant I to the market J. That's why for variable we input is the var. And we have another binary variable is the uh, y plant I and level Z. If it's open, then yiz will equal to 1. If it's not open, then yiz will equal to 0. And the next step we will input the objective function. So our in our objective is to minimize the total cost. The total cost will equal to the fixed cost plus the variable cost. So this is the function for the fixed cost, and here is the function for the variable cost. And next we will input the constraint. The first constraint is the total quantity shift from the market I to market J to all the market to all the plant to the market J will equal to the demand in market J. That is the first constraint. And the second constraint is all the quantity shift from the market I to all market has to less than or equal to the capacity of the plant I. Okay. Oh, I don't need to input the uh, all the quantity shift has to be a larger or equal equal to 0, because here I already input is integer plus. It means it has to be larger or equal to 0. Then I will get the result here. That is for model, but for data we have to input data for those parameter, right? So I will input my connection the sheet to my file. My file here is I already close it, but here is han. So han.xlsx. Then I want to read n from the sheet 1 and the cell A9, and the number is 5. Uh, and also M is from the sheet 1 cell T3. Demand D is from the sheet 1 from C10 to C10, and so on and so forth. And then you will let it run this. Wait, let me show you. It will be in OPL. So here this file, so I put han here, the file name han. And okay, they already show me the result here. This is the decision variable. We have the result for uh, the quantity shift from the plan I to the market chase here, and the binary variable for Y. Or you also can X to shift right. So it means that you want to export your result to here, sheet 3. So I choose sheet 3, and from A6 to E10, so they will input your decision variable here, the result here for you. So that is how you use the simplex to solve your problem. And I will give you some exercise next week so that you can practice more. Okay, that is the problem about capacitated plan location model. Here I already input the code so that you can take more careful look at this. Okay, now I move to the phase 3. That is about the gravity location model. So after choosing a region, uh, they choose the region maybe South America, Asia, and Africa. So after choosing choosing the region, they have to choose the uh, area, the country or the city specific location. So it's when we use the gravity location model. And we have xn and yn is the coordinate location of either the market or the supply source n. And fn is the cost of shipping one unit for 1 mile between the facility and either market or supply source n. Dn is the quantity to be shipped between the facility and the market or the supply source n. And we have to find the location of the uh, selected facility, that is x and y. So x and y is the coordinates, the value that we want to find, right? And we can calculate the distance, the small dm between the facility at this location and the supply source and the market and given by our or the market n. Okay, and we have two ways to calculate the distance. The first one, we use the rectilinear rectilinear and the second one is Euclidean. We already learned this one in the course of uh, principle of logistics and supply chain management. And here I just introduce you about Euclidean distance, that is equal to the square root of uh, x minus xn take the square plus y minus yn take the square. Okay, then after we calculate the distance from the location of selected for the facility, we calculate the total transportation cost, that is equal to the distance multiplied by the demand multiplied by the cost, then you take the sum. And our objective is we want to minimize the total transportation cost. So let me give you this example. So I have the supply source And the market, I have 1, 2, 3 supply source and 5 markets. And I have the information that is the transportation cost per ton mile uh, in the Buffalo is $0.9, or in Louis is 0.85, and the quantity are that they have to deliver from Buffalo is 500, from Louis is 700. And we also have the coordinate of each location of each supply source or markets. And now we have to find the location for selected facility so that we can minimize their transportation cost. So also we can use the solver in Excel to solve this problem. So let me show you. So here we have all information that they give us, and I calculate the distance from the facility location that is unknown. This one is decision variable, but I calculate the distance from this location to each supply source and markets. So we use the Euclidean distance to calculate this. So this one is the square root of uh, x minus xn, take the square, plus y minus yn, take the square. Then we will have the distance from the first supply source to the facility location. And the same, we just copy this formula for uh, the second, for the cell h, the array h4 to h10. Then we can calculate the column distance, and then we calculate the cost, that is equal to the transportation cost per unit times the quantity they have to deliver and times the distance. And the same, you just copy the formula from this cell and paste it for the cell from I4 to I10. Then after that, we calculate the total cost, that is equal to the sum of all the costs here. So we just use our data solver. Then here we want to minimize the total transportation cost, right? So we want to minimize this value. Then by changing the variable cell, that is this one, C14, C15, we don't have any constraint here, so we will solve. Then they will solve you maybe I will input here is integer, so that they will give you the better value. So I add this one, the decision is integer. So, okay, so we can see that is the x and the y for the location selected is 700 and 1200. And as we see in reality, when sometimes these are location is not available. And yeah, we can see here this is actually the same as location of the first supply source, the buffalo. So what we do is we will choose another site that near this area but available. Do you still remember this one is used for the this one is we are using the infinite set approach. So we just choose the best site, then after that we will choose available site nearby that location. Okay, so that is, oh, okay, there is a mistake here. It should be 700. So here is 700, 700 here, and we have 700 here. Okay, okay, so far that is uh, how I already teach you how to input, how to construct the objective function, constraint, how to use solver and Cplex. So next week I will give you more exercise so that you can practice by yourself. Okay. Okay, thank you.